It's Alex here from Texture 202. Today we'll be taking a look at converting binary to hexadecimal. So let's begin. So just a quick refresher. Binary is in base 2 and consists of zeros and ones only. Then there's base 16, also known as hexadecimal. Base 2 is also known as binary, by the way. And hexadecimal uses 0 to 9. No, that does not look like a 9. And it uses letters A to F. So with that in mind, let's convert the following binary number that we have here. So the way I like to do this, it's actually pretty simple. So what you want to do is split the binary number into groups of 4 bits from right to left, and then convert each group into its hex digit. So let's grab the first 4 bits here, and then grab these 4 right here. And what we're going to do now is the following. This is a little neat trick I learned that I absolutely love. So what we do is we just draw a line like this and we put 1. Then to this 0, we draw a 2. To this 0, 4. And then to this 1, 8. And then what we do, I like to do at least, and I find it very helpful, is I just circle the numbers that correspond to a 1. So in this case, it is 8 and 1. So that makes 9, right? Because it's 8 plus 1, which equals 9. And then we're going to do the same thing, on this side. So we got 1, 2, 4, and then 8, right? And then in this case, we are circling 8, we're circling 1, and we're circling 4. And then we're going to do 8 plus 4 plus 1, which will give us 13. Okay, so now we have the numbers 13 and 9. So my 9s are not that great. All right, there you go. Okay, so if you guys recall, not too long ago, I mentioned that the hexadecimal system uses digits from 0 to 9. So this 9 here that we have, it's in the clear. But we have 13, right? So in the hexadecimal, because we use letters as well, that range from A to F, right? Like if we just take out the letter system for a second, you look at the 13 and then you'll be like, yo, it's out of range, right? So in hexadecimal, if we break down the letters, here's what they mean. So A is equal to 10, B is equal to 11, C is equal to 12, D is equal to 13. You guys see now, right? So if I highlight this, 13, there you go. That's what we need. But let me just complete this for you guys, just for your sake. So E equals 14 and F equals 15. Oh yeah. So with that in mind, and as I highlighted previously, D equals 13. So in this case, if we look at our question here, our answer will be B, right? Because 13 in base 16 is actually D. And because we had our other number was 9, that's within the 0 to 9 digit range, it remains the same. So the final answer is D9. Okay, so this was an example where we were dealing with 2-digit hexadecimal, right? The answer was a 2-digit hexadecimal. Now let's try something with a little more numbers. So here we got another binary to hexadecimal. And again, we're going to do the same thing. Group these into 4 bits. So this is 0, 1, 2, 3, or sorry, 1, 2, 3, 4, right? And then we'll do the same here. That's 4, and that's 4. And quick side note, if we had a few more digits, say 1, 2, 3, right? And you're like, oh, shoot, that's not 3 digits. But the solution here is pretty simple, and it's no need to panic. Oh, oops, there should not be a 3, but let's say it's 1 like that. What you can do is add a filler. So usually a filler will be a 0. So we can just put 0. Even though there wasn't a 0 before in this section here, we can add it for the sake of simplicity and the process, right, for our understanding. So just wanted to quickly point that out. Okay, so we're going to do the same thing like we did previously. We're going to label 1, 2, 4, and 8. And we got this here, so that's 6. Just for the sake of making some room, I'm just going to erase. So then this one here is 1, 2, 4, 8. If we do that, we are using all 4 in this case, which is crazy. So we'll do 8 plus 4 plus 2 plus 1, which equals to 15. So I'll just put this here in our, let's call this our little basket, right? So I'll erase this, and then 1, 2, 4, and 8. Okay. So here we're using 2 and 8, right? Again, quick review. You want to circle the number here when there is a corresponding 1. If it's a 0, it's off, right? Think of it this way. 1 equals on, and 0 equals off, right? There's no point of circling something that's off. So yeah, and then that will give us 10, right? So if we look at our basket here, we got 10, 15, 16. So again, let's write down what A equals. So that's 10. We got 0 to 9, right? The digits, letters. And if I have an exam where I have to convert binary to hexadecimal or any other base to hexadecimal, I always like to write out the letters because, you know, sometimes you're in a crunch, obviously, on an exam. But you might forget, right? Because you're stressed out. So I just like to write them out like so. So we got 11, C equals 12, D equals 13, E equals 14, F equals 15. Okay, awesome. So now we got 6 here. So 6 can remain, right? That's good. It's in the range between 0 and 9. Then we got 15 here. So 15, as we can see in hexadecimal, is F. So we write down F. And then we got 10 here, right? 10 is A. So our final answer is AF6. So let's see. And that is B, AF6. Okay. And that's how you convert binary to hexadecimal, guys. If you found this video helpful and useful, please make sure to like and subscribe. If you want to see more videos like this or have any questions, please comment down below. And I hope to catch you guys all in the next video. And take care. Bye-bye.